Okay, let's jump right into this explainer. Today, we're taking a look at large language models, or LLMs, and we're going way beyond those simple chatbots you've probably played around with. We're talking about LLMs as actual, highly powerful engines for massive business automation and internal decision-making. So if you're a business leader trying to cut through all the hype and figure out exactly how this tech creates real, tangible value for your enterprise, you are definitely in the right place. To respect your time, here's a quick look at our agenda. We'll start with the enterprise AI engine, then peek inside transformer architectures. After that, we'll decode self-attention, talk about automating operations and decisions, and wrap up by navigating LLM risks. All right, Section 1, the enterprise AI engine, moving beyond simple chatbots. There's a quote from IBM that I think absolutely hits the nail on the head here. It says, LLMs represent a major leap because they're the first AI system that can handle unstructured human language at scale. Think about that for a second. For decades, we've been stuck relying on rigid, programmed systems, keyword matching, right? But now, we're finally moving past that. We have systems that actually grasp context, nuance, and reasoning. That means your business can now process the literal mountains of unstructured data you generate every single day. But we need to clear up a common myth right out of the gate to truly leverage this. At their core, these models aren't actually thinking. An LLM is essentially a giant deep learning statistical prediction machine. All it does is repeatedly predict the next token or word in a sequence based on massive patterns it's learned. It doesn't know the final answer before it starts typing. It's just using statistical relationships to make its absolute best guess one step at a time. It's an engine of probability, not consciousness. Though, when it's crunching trillions of tokens a second, it's really easy to blur the lines. Okay, Section 2, inside transformer architectures. Let's look under the hood. To really appreciate where we are today, we have to look at where we came from. When you compare older sequence models like recurrent neural networks to the modern transformer architecture that dropped back in 2017, the leap in capability is staggering. See, transformers allow for massive parallel processing. Instead of reading data strictly in order, which totally bottlenecked older systems, transformers process vast amounts of data simultaneously. This efficiency lets them handle way more parameters, the internal configuration variables, and gives them a vastly superior grasp of long-range context across your corporate documents. Now, before any of your enterprise data actually enters this engine, it gets broken down into things called tokens. A token could be a whole word, part of a word, or sometimes just a single character. This process, tokenization, standardizes everything. It ensures the model can consistently handle rare or completely new words without breaking a sweat, just by chopping them down into machine-readable bits. And to process those tokens, full transformers use a two-part setup, an encoder and a decoder. It's kind of like having a professional translation team on staff. The encoder takes the input, say a really complex prompt from one of your data analysts, and turns it into an intermediate mathematical representation. Then the decoder steps in, grabs that math, and turns it into useful text output. Both parts are enormous neural networks working perfectly in tandem to generate your result. Moving on to Section 3, decoding self-attention. This is all about contextual understanding. Self-attention is basically the secret sauce. It's what allows the model to flexibly focus on what actually matters while ignoring the fluff. Imagine self-attention vectors as a highly efficient corporate analysis team. Every token gets projected into 3 distinct vectors: a query, a key, and a value. The query is what a token is looking for. The key is the data it holds, and the value is the relevant info that comes back, which gets scaled by calculated attention weights. It's an absolutely brilliant way for the model to mathematically weigh the importance of every single word against every other word. Let me give you an example of how this handles the inherent messiness of human language. Say you have the sentence, "The animal didn't cross the street because it was too tired." How does a machine know if it means the animal or the street? Well, by calculating those alignment scores between queries and keys, self-attention figures out that animal is mathematically way more relevant to it than street is. It assigns a higher weight to that relationship. Boom, context captured. And the crazy part? This doesn't just happen once. Transformers use multi-head, multi-layer self-attention. By stacking these attention layers on top of each other, the engine builds a progressively deeper, more abstract understanding. The first few layers might just figure out basic syntax and grammar, but as your data moves deeper into the model, it starts grasping complex sentiment, deep operational context, and huge thematic links across an entire document. Let's jump to Section 4, automating operations and decisions.
How we actually drive business value.
So, one of the absolute fastest ways to see ROI here is through retrieval augmented generation, commonly known as RAG. Honestly, RAG is a total game changer for the enterprise. Instead of burning months and millions of dollars retraining a model from scratch on your private data, RAG connects a pre-trained model directly to your external enterprise knowledge bases. A user asks a question, the system pulls the relevant secure info, drops it straight into the LLM's context window, and generates a highly accurate data-backed response. It's fast, it's cost-effective, and your data stays secure. Because these models have such deep context and access to your company data, enterprises are automating incredibly diverse, high-level operations. We're talking about rapidly generating and debugging application code to accelerate your software dev cycles, or text summarization, taking massive research papers or corporate histories and distilling them into instant insights for decision makers. It does sentiment analysis on customer feedback at an unbelievable scale, and it powers real-time AI assistance for customer care. These aren't just toys, they are literal tools for autonomous business operations. But what if you need a model specifically tailored to your niche industry? That's where we see the difference between pre-training and fine-tuning. Pre-training is that massive, ultra-expensive phase on billions of words that gives the model its broad, general knowledge. Fine-tuning, though, is how you adapt it just for your enterprise. It's a targeted, efficient process using smaller datasets. You can take a general model and train it purely on your proprietary legal contracts or your specific medical files, creating a hyper-specialized, domain-specific tool. And this all rolls up into complete business alignment. We frame these fine-tuning steps as teaching the model to strictly play by your company's rules. We use supervised fine-tuning to give the model specific functional capabilities. Then you've got reinforcement learning from human feedback, or RLHF, for stylistic alignment. That ensures the AI sounds exactly like your brand, whether that's highly professional or super empathetic. And finally, instruction tuning makes sure the model actually follows complex, multi-step instructions perfectly aligned with user intent. Which brings us to Section 5, Navigating LLM Risks. Because we have to deploy this responsibly. Look, the major hurdles for enterprise adoption basically fall into 3 core categories. Number 1, hallucinations. That's when the model confidently spits out completely false or misleading information that sounds incredibly plausible. Number 2 is data security. If you're feeding proprietary enterprise knowledge into these tools, you need ironclad guardrails so you don't accidentally expose sensitive IP. And number 3, compute costs. Running and getting predictions from these massive models takes a staggering amount of computational resources and electricity. I mean, a single AI query can use nearly 10 times the electricity of a standard web search. So, overcoming these serious challenges demands robust AI governance straight from the top down. Having processes, standards, and guardrails is absolutely non-negotiable. Enterprises have to utilize techniques like red teaming, where you literally attack your own model to expose its weak spots, and you have to evaluate them against rigorous benchmarks. You need hard, quantitative scores for accuracy, safety, reliability, and operational efficiency to ensure your systems aren't just smart, but actually secure and cost-effective. So, as we wrap up this explainer, the big strategic question you need to be asking yourself isn't if you're going to use large language models. Frankly, the market has already made that decision for us. The real question is how will you govern and orchestrate these AI engines to carve out a decisive, safe, and highly profitable advantage? Are you ready to lead your enterprise into the AI era, or will you let your competitors figure it out first?